What is in a landfill? Truth behind the Landfill series, Module 2. Not all trash is created equal. Neither are all landfills. So let's explore. Why this matters. This isn't just garbage in, garbage out. What's inside determines how toxic, how gassy, and how long-lasting a landfill becomes. Understanding landfill design can mean the difference between a managed waste site and a slow-motion environmental disaster. The choices we make upstream, meaning what we toss and how we sort, ripple all the way down to landfill safety and lifespan. Alright, now it's time to open the trash can and look inside. This part shows you exactly what we're burying, why some items turn toxic time bombs, and how the stuff in the pile determines whether a landfill is manageable or mess for centuries. Pay attention because half the solutions start with knowing what the problem is. The usual suspects. Organic waste, like food scraps and yard clippings, create methane. Paper and cardboard sometimes rot and decompose, but some mummifies in anaerobic conditions, meaning conditions with no oxygen. And plastics are basically forever residents. Did you know that in modern Canadian landfills, paper products can still be found to be perfectly legible after over 30 years underground? Here's the thing about landfills. They're not mysterious wastelands, they're layered time capsules. We know exactly what's inside because we've dug them up, as gross as that sounds. Over half the material is stuff that we handle every single day. Organic waste like food scraps and yard trimmings, paper and cardboard and plastics. But these everyday items are not innocent. Organics are the methane factories. When they break down without oxygen, they feed bacteria that churn out methane. This is the greenhouse gas that's over 25 times more potent than CO2 in a 100-year time frame, but 80 times more potent than CO2 in the short term. So paper and cardboard, they can decompose faster, but they still release methane when trapped in anaerobic layers. And plastics are biological fossils in the making. They fragment into microplastics, leach chemicals, and never truly go away. Here's the kicker. Every load of trash changes the landfill's chemistry. Add more food waste and you speed up gas production. Add more plastics and you create long-term leachate challenges. Understanding the mix is how we figure out what we must stop putting in there in the first place. Now we have the silent killers. E-waste, toxic metals and plastics, batteries, mercury, cadmium, and lithium, and household chemicals and paints, the volatile organic compounds, or VOCs. Did you know improper battery disposal is responsible for hundreds of landfill fires in North America each year, fires that sometimes burn underground for months? Some landfill contents don't just sit there, they poison the whole system. We call them silent killers because their danger isn't obvious to the casual eye. E-waste, like old phones, TVs, and computers, leak heavy metals, lead, cadmium, mercury, etc., into landfill leachate. These materials do not degrade, so once they're in the environment, they are there for good. Batteries, they are both a chemical spill risk and a fire hazard, especially in big piles of compressed waste where heat builds up. Household chemicals, paints, and solvents release volatile organic compounds, VOCs, into the air and create toxic cocktails in landfill leachate that are incredibly expensive and sometimes impossible to fully clean out. This is why proper disposal programs and producer take-back systems exist. Once this stuff is in the pile, it's a multi-generational problem. Prevention is cheaper, cleaner, and safer than trying to extract the toxins in an active landfill. Anaerobic hell. Why things don't decompose like we imagine. It's basically a lack of oxygen and moisture control, among others. There's a case study where they excavated a 40-year-old hot dog and a perfectly legible 30-year-old newspaper. So the takeaway here is that landfills are designed to store, not compost. Did you know that researchers and journalists have documented food items like hot dogs and heads of lettuce that appear almost intact after decades in anaerobic landfill conditions? So here's the Mythbuster moment. Biodegradable in a landfill does not mean fast disappearance. Landfills are designed to be sealed, compacted, and oxygen poor. That's the opposite of the conditions needed for normal decomposition. Without oxygen, decomposition slows to a crawl. Microbes shift from aerobic, oxygen-loving, to anaerobic, oxygen-avoiding species, which break things down differently, producing methane and acidic leachate along the way. And the result, perfectly preserved, decades-old food, newspapers you can still read, even intact lawn clippings. Archaeologists of trash have pulled 40-year-old hot dogs from the ground that look disturbingly fresh. This isn't a failure, it's by design. Landfills are storage systems, not composters. The trade-off is that they become slow-moving climate machines, steadily leaking methane for decades. That's why reducing organics at the front end isn't just nice, it's climate critical move. Landfill design, engineering versus chaos. Not all landfills are created equal. Some are feats of modern engineering, and others are ticking environmental time bombs. Anatomy of a modern landfill. Liners, that are clay and plastic, leachate collection systems, and methane capture. Then we've got daily cover to reduce pests and odor, and environmental monitoring of groundwater and gas emissions. Did you know some Canadian landfills use biocovers, layers of compost that literally eat methane before it reaches the air? How cool is that? If they can do that, one would hope we could all do that. A properly engineered landfill is not just a hole in the ground. It's a highly controlled contamination system. Picture it like a giant layer cake of protection. At the bottom, the thick plastic liners and layers of compacted clay keep contaminated liquids from leaking into groundwater. Every day, incoming waste is compacted and covered with soil or alternative daily cover to reduce pests, odors, and windblown trash. On top of that, they're monitoring wells and sensors to track leachate levels, gas buildup, and signs of liner stress. It's not perfect, nothing man-made is, but the goal is to contain hazards for decades or even centuries. The science and engineering buys us time, but they don't erase the fact that the waste is still there, slowly producing methane and leachate. The real win comes when less dangerous materials goes in from the start. High-tech examples. Did you know Edmonton's system diverts or processes up to 90% of residential waste? It's one of the highest in North America. Edmonton's Waste Management Center is often called the gold standard for integrated waste handling in North America. It isn't just a landfill, it's a multi-stream waste hub. They divert organics to a large-scale compost facility, they recycle metals and plastics, and turn landfill methane into electricity that actually powers thousands of homes. Every ton of waste that doesn't go into the main landfill cell extends its lifespan and cuts climate emissions. Methane to energy streams capture gas that would otherwise contribute to climate change and instead put it to use as renewable energy source. It's not perfect, you can't capture 100% of methane, but it is a massive step up from simply venting it into the atmosphere. The Edmonton model shows what's possible when a city designs waste management for the long game rather than quick fixes. Rogue dumps and outdated sites. Did you know in Canada there are still thousands of old dump sites, some dating back to the 1950s, sitting unlined and unmonitored, quietly leaking into surrounding ecosystems? On the flip side from Edmonton, we have rogue dumps and outdated landfill sites, the environmental equivalent of a ticking time bomb. These sites often lack liners, so leachate can flow straight into the groundwater. There's no gas collection, so methane leaks freely into the atmosphere, and without daily cover, trash attracts scavengers, breeds pests, and creates fire hazards. Illegal dumping hotspots are even worse. You'll find everything from appliances and tires to barrels of industrial chemicals just rotting in the open. These sites are unmonitored, so when contamination happens, it can spread for years before anyone notices. Cleanup costs fall on taxpayers, and in rural and remote areas, sometimes the cleanup never happens at all. Is a safe landfill possible? We've seen the best, Edmonton. We've seen the worst, random in the world. Now, let's get real. Even if the safest landfill is a compromise, this section takes a hard look at the limits of engineering and why the ultimate solution isn't better landfills necessarily, it's needing fewer of them in the first place. The good, the bad, and the reality check. Did you know that even the most advanced landfill is typically designed to only contain waste for about 30 to 50 years before significant liner deterioration can occur? Here's the inconvenient truth. Even the best engineered landfill is a temporary fix, not a permanent solution. Liners degrade over decades, sometimes faster under chemical or temperature stress. And once they fail, leachate can move into soil and groundwater, sometimes undetected for years. Gas capture systems are good, but they're never 100% efficient. Methane escapes during installation, maintenance, or from older parts on the site. On top of that, these sites require perpetual monitoring. We're talking generations of maintenance, replacing pumps, repairing liners, keeping leachate treatment systems running long after the landfill has been closed. That long-term cost and burden doesn't go away. It just shifts onto future taxpayers. Landfills are not time capsules that stay inert forever. They're engineered delays, holding back environmental harm as long as humanly possible. Beyond the landfill. Did you know that if every Canadian reduced their landfill waste by just 1 kilogram, or roughly 2 pounds per week, we could keep over 1.9 billion kilograms, or more than 4 billion pounds, of trash out of the landfill every year. That's roughly the weight of 300,000 adult elephants. The real solution isn't about making landfills safer, it's about making them obsolete. Zero waste initiatives focus on preventing waste from entering the landfill in the first place, reducing, reusing, repairing, and recycling. Cities like Kamikatsu, Japan, have achieved over 80% diversion rates by designing systems where materials are sorted into dozens of categories for reuse. The circular economy takes this a step further, designing products and systems so materials are kept in continuous use. That means eliminating planned obsolescence, rethinking packaging, and investing in reusable infrastructure. These strategies don't just reduce landfill volume, they reduce the extraction of new resources, cut greenhouse gas emissions, and build resilience into supply chains. Every product we keep out of the landfill is a long-term win for both the planet and our wallets. So what is the bare minimum each of us could do to help make landfills less toxic? Firstly, organics. If it can rot, it should compost, not be put in a landfill. In a landfill, it turns into methane and toxic leachate. In compost, it turns to life. Then we have tech waste. Phones, batteries, cables, these are all poison in a pit. Always take them to e-waste depots. Landfills and tech do not mix. Then we have chemicals. Paints, cleaners, sprays, they don't disappear. They brew into toxic soup. Cities provide hazardous waste drop-off sites for exactly this reason. And then we've got plastics. Plastics are forever. If you can't avoid them, recycle them properly where accepted. At least give them a second chance before they get buried alive. This is the minimum standard. Compost, protect, dispose right, and recycle. Do just these four, and you're already a part of the solution. You can help. Did you know that if every North American household cut landfill waste by only 10% this year, we could prevent over 21 million tons of trash from being buried, enough to fill the CN Tower almost 12 1,000 times. Right now, landfills are a necessary evil, but they're not harmless. Every bag you keep out of the bin is one less burden on the earth, one less methane puff into the air, one less toxin in the water. The power to shrink our landfills isn't locked in some government vault. It's in our kitchens, in our shopping carts, and in our daily choices. Small actions stack up fast, and together they turn a mountain of waste into a molehill.